Hello. How's everybody feeling? Good? Are we good? We're not going to be the post-lunch slump? That's right, you're not, because you're going to learn so much from these two wonderful people. Please welcome Jonathan and Aaron from Leidos to take you through fortifying data resilience.
Thank you, everybody. So today we're going to talk to you about a use case that we had at Leidos called fortifying data resilience. We're going to first go through the intro, then we're going to talk about the actual DR project, then full details and steps on our implementation, and then testing, and then finally results. So my name is Jonathan Buckner. I am the Director for Performance Engineering for Leidos, and this is...
I'm Aaron Toombs. I'm lead data engineer, responsible for getting all the data into our systems and through, and any sort of admin work that goes along with that.
So we'll start off with the forward-looking statements. So before we dive in, quick disclaimer, we'll be making some forward-looking statements, and translation, we're talking about the future, and as my lawyer reminds me, my crystal ball doesn't always work. So things may change, of course, over time. So the first question would be, what is Leidos exactly? So thinking about it, many of you may have come here on airplanes, and of course, if you had to stand up through TSA, put your hands up like this. Yes, we are the company who makes those machines. Outside of that, we do a lot of work with different agencies, such as defense and intelligence agencies, civil, health, and a wide variety of others across various corporations around the US so that we can provide services to the federal government. These are contracts from small operational support all the way up to multi-billion-dollar, multi-year contracts spanning over a wide scope of different agencies. So why we're here to talk to you today is to describe a particular threat that we had inside the environment where we were trying to solve some use cases which you see here. So first, our CISO approached us and said, hey, what happens if our critical data that we have inside of the Splunk Enterprise platform were to get infected by ransomware? Like, what do we do? How can we recover? Second, let's say that we had a scenario where an administrator were to make a mistake. For example, you all know that if you're in Splunk and you're messing around with frozen time period in seconds in production, 1-0 mistake can cause irreparable data loss. And then third, what if there's a catastrophic event? If we have some kind of large outage in our data center, how can we recover from that to be able to bring our critical security and operational data back into the platform? In terms of requirements for how we were approaching the problem, we had to first ensure that it met what the security team needs, which is that the data has to be immutable. Any copy of the data that we were going to be putting inside a solution could not be modifiable after writing, could not be altered, changed, updated in any way, shape, or form. Also, we needed to be able to rapidly recover the data. So, as soon as we get it up there, there's a timer in terms of how long we need to be able to have in order to get that data back into a usable state. We want to make sure that we were cost conscious about our solution, that it didn't cost the organization millions of dollars to solve the problem that we had. And of course, user-friendly, being able to use native tools, which our users are used to using, so that they didn't have to learn brand new technology, new languages in order to interact with the data. A little bit of background about our environment and the resources that we have is that we have a decently sized Splunk implementation where we have over 160 Splunk servers. I know that we haven't mentioned Cribl workers here, but we have, I think, over 40 Cribl worker nodes currently inside the environment, 5 petabytes of data that's currently stored, 13 terabytes worth of data a day, 1,500 unique source types, hundreds of users, and tens of thousands of devices that are reporting in. And of course, as a manager that many of you also may be out there, I'm doing this with limited resources. So I had 5 full-time Splunk engineers, and they are also not only managing Splunk, but Cribl. We have a stack of other network monitoring tools, so these folks are really, really busy. And we thought, how can we solve this with our existing technology that we had? So we had a Cribl implementation as we were thinking about the possible ways to solve this problem. So this takes a look at the data flow as we started the project. It has morphed a little bit to get to the point that it's at now, but Aaron will go more into detail that later. But we are basically have infrastructure, global around the globe that basically we feed data in to make sure that it can finally end up inside of Splunk. In terms of what we considered to meet the use cases which we defined before, is that we thought about, okay, we could do this in something like Splunk Cloud. But as many of you know, that could be very, very, very cost prohibitive. We also could have purchased some kind of alternative on-premises storage solution for this. But the problem with that is that it requires potentially millions of dollars at our current scope and scale of a CapEx purchase, which also was not the ideal situation. We could use a third-party solution such as a Snowflake, which is a viable option, but the worst part about that is that you have to then teach your users how to interact with that data instead of using the SPL that they're used to, using SQL then to be able to retrieve that data back and search it and use it. And then we thought about, okay, well, how can we do this with our tools that we already have expertise in, such as Cribl and AWS? And that's what we ended up going with. So for data immutability, we were able to solve that with having object lock and compliance mode turned on the buckets which we're sending the data to. What that means is that you cannot alter, modify, change, do anything to the data unless you actually remove the entire account. So it's very, very safe and very, very secure. In terms of rapid recovery, Aaron and the team, they worked together to create CloudFormation templates so we could easily spin up and spin down environments while we're working on ensuring that a potential threat is out of the environment, out of the network, to make sure that we had access to the data in near real time based upon a few clicks of a button. In terms of it, the cost, we were able to use intelligent tiering to where we're really, for like pennies on the dollar, able to create large volumes of storage and store this data for a very long time that cannot be modified or changed. And user-friendly, of course, because using Cribl's replay function, we're able to take the data and then bring it back into a Splunk native environment such that we can search it with the language which we're all used to and familiar with. And so next, I'll hand it over to Aaron to go through the details in terms of how we achieve these objectives.
Thank you. All right, so my job was to put this into a format that was going to work and get our data through and make sure that we could prove that it was working properly. The first question we needed to consider was, how do we get all of our data over to S3? In the diagram that Jonathan showed earlier of our data flow, you may have noticed that only a portion of our data was going directly into Cribl. Another portion of that data was coming through Splunk heavy forwarders and bypassing Cribl entirely on its way to the indexing tier. So we had to make sure that we were able to move that data so it all goes through Cribl to use this. We also needed to consider how we properly secure that data to make sure it's safe, how we want to format our stored data, and how we want to get our data back. The design we came up with uses still our existing heavy forwarders in some scenarios, still has part of our data going directly to Cribl, and then Cribl is feeding two sources for us, our Splunk indexing tier and our Amazon S3 bucket. For our heavy forwarders, we redirected those, so instead of going through the indexers directly, they go through Cribl on that path so that we can still use Cribl in order to be able to achieve this solution. In order to accomplish this, we had to set up in basically 3 environments. Our Splunk software, we created a special app that would move the data from the heavy forwarders over to Cribl and add some features so that we could do some stuff we'll talk about in processing. In AWS, we needed to design the CloudFormation templates, and we needed to set up a bucket with an S3 object lock. In Cribl Stream, we had to take a look at the options we have for partitioning, how to configure the destination and source for S3, the use of an output router, and we had to make sure we deployed the updated routes for everything to be used. The first thing we looked at here was how to get the data from the heavy forwarders over to Cribl. In doing this, we wanted to consider that data coming through a heavy forwarder has already been processed by Splunk. It may have changes to the index, it may have had some data consolidation happening. We don't want to lose any of that. We also don't want to consume unnecessary resources by having Cribl reprocess data that has already been handled. What we came up with for this is designing a custom app that just adds an additional indexed field to the data as it goes through and basically says, this came from a forwarder. We use that field later in our Cribl pipelines, so that in our Cribl routes, I apologize, so that we can avoid reprocessing that data. I will show that more in a moment. In AWS, we had to configure our bucket with object lock. If you're setting something like this up, you do not want to turn object lock on in compliance mode until you have completed all your testing. Once your data is there and you enable compliance mode, there is no turning back. It's staying for whatever length of time you've set on that bucket. In our case, it's set to 365 days. So if I send up bad data, it's there for a year and there's nothing I can do with it. So if you do choose to use this method, make sure you've done your testing before you enable the compliance mode. The next thing we looked at for AWS was using CloudFormation to create a template which would allow us to spin up a recovery environment very quickly and without necessarily having somebody on hand who knew every little step we were going to need individually. The ability of the template to accept some input variables, things like how many worker nodes are we going to need, how many Splunk servers are we going to need, is an advantage there. And we were also able to program in things like setting up account permissions and making sure that connections from, for instance, our VPN network would work out to our AWS environment. So all of that is built into a template that can be quickly run. Our template includes spinning up Cribl leader and worker nodes. It includes everything we need to be able to run a Splunk environment for us. And we just have to maintain a separate AWS bucket that will allow us to update files with installation files and such as we change things in our environment. That bucket does not have object lock on it. It is used just for storing these templates when we need them. Finally, we had to look at Cribl configuration. One of the key things you have to consider in using an S3 bucket is the partitioning strategy. In short, partitioning is the layout of the folders or directories that are going to be created in AWS. There are some guidelines on these that you should try and keep cardinality below 2,000. As we went through and examined our data, we figured out that we could look at our source types, our indexes, and break down time down to the point of an hour. So at any given time as we create these buckets, we can figure out data that came in a specific hour for a specific index. So as long as we know where the data is that we're looking for and what index it would have ended up in, when we go to replay data down the road, we will have the ability to narrow it down to specific portions if we need to. When configuring the S3 destination, you have to program in your S3 information, and you need to include an API key and pair in order to set this up. Those security features have to be rotated on a regular basis, and when you do so, when you update the AWS key and pair, you should restart all of your Cribl workers. They may not take the updates until they are restarted, which could cause problems with your data flow if you're not aware of it. There are also several options for tuning your file size, how long files stay open, what kind of compression you use within the settings here. This isn't something where there's a one-size-fits-all solution. You have to kind of go through and see what's working for you and what you might need to change. Once we got everything configured and we were ready to start flowing our data through Cribl, we set up an output router. If you're not familiar with an output router, this is basically a way to split your data to multiple locations. For us, we want some of our data to go to S3, and we want some of our data to go to Splunk. In our case, actually, it is all of our data going both ways. So within our output router, we set a filter expression just of true. That means everything goes to both paths. And you'll note that final on the first item is set to false so that the data flows through. If you set the first one to final, it will never reach the second one. Finally, we went back and we had to adjust our routes in order to make sure that we had configuration that would allow this data to go through. As I mentioned earlier, we have Splunk heavy forwarders that are already processing a portion of this data before it gets to Cribl. We didn't want to reprocess that data, we don't want to change anything, and we don't want to use the resources to do it. What we did in order to handle this is we created a route at the very beginning of our setup that just checks for the field we created in the Splunk app I talked about. If that field is there, it immediately just sends that data through to S3 and through to the Splunk indexers without reprocessing it. So we are not adding additional load to the workers processing data that's already been manipulated by the heavy forwarders. Any data that does not contain the Splunk HF field for us then falls through and goes through the rest of the routes for its normal processing before going out. Each one of these routes is configured to use the output router so that it'll send to both destinations. Another option on how to do this would be to develop a route at the very beginning that just sends everything over to S3 and then allows all of the data to fall through to the regular routes. You could do that without having to implement an output router, but for us, the disadvantage of that is that our data would have been stored in two different formats. We would have had one set of data that already had been processed by Splunk, and another set that had not yet been processed and therefore didn't contain our destination indexes and such. So we chose this way to make sure that all of our data is formatted specifically for Splunk when it comes back in. After getting all of this in and doing our testing, we needed to be able to prove that the solution is working. In order to do that, we tested our CloudFormation templates. We tested the installation of the applications from the files we had saved, made sure that we had valid licensing codes and that we knew exactly what we were going to need to spin up our new environment. We tested Cribl Replay, the ability to grab specific data from our S3 bucket, play it back into our new AWS environment, and send it on to our indexers. And then we compared the data sets and made sure that the results are valid. When we spun up our environment for testing, we spun up a handful of machines, just 2 search heads, 2 indexers, 2 worker nodes, and the accessory machines that are required by Cribl and Splunk. I've included a little bit of information on the machine sizing here from AWS. This is what works for our environment, but of course, machine sizes are customizable inside of the template. Our CloudFormation template, as mentioned before, includes our security groups. It includes the rules needed to support the traffic between resources, and it handles things like required drive mounts for us. In terms of setting up Cribl itself, we installed our software manually. We added the licensing requirements. We configured worker nodes. We did adjust our worker process count to 20 processes each, based on the available resources on the machine. We added in our S3 collector, and we added our indexers as a load-balanced destination. In Splunk, in the AWS environment, we again did basic configuration, adding our license to it. We configured our search heads and search peers, and we modified the parallel ingestion pipelines to 6 on each indexer. If you're familiar with Splunk guidelines, that is well above their recommendation, but it is relevant to the remainder of this. As we tested this, we basically decided on a specific day we wanted to pull back data from. We retrieved 1.23 terabytes of files from S3 for that single day, and we indexed it. After indexing, it was 7.2 terabytes approximately. It took, for the Cribl Replay and the full indexing, 8 hours and 10 minutes to pull back that 7 terabytes of data. We went through, we did comparisons, we made sure we got the indexes we expected, the source types that we expected, we checked our event counts, and we looked at individual results and made sure that everything looked appropriate on it. At the end of that, we did some calculations. What's the math? How long is it going to take us to recover? Will we be able to meet our objectives? With the configuration changes we made and the sizes of the machines that were spun up in AWS, we found we can recover about 450 gigabytes of data per indexer worker pair per hour, which is a huge volume. It's well above what you would expect inside a Splunk. That parallel ingestion pipeline is part of the reason for that. It allows those indexers to work way harder than what they're normally set to. And note that part of the reason that works in this environment is because those indexers don't have to do anything else. There are currently 0 searches running in that environment that they have to respond to, so we aren't tying up cores on anything else there that would need to be done. But again, this is not part of the Splunk guidelines, so keep that in mind as you're doing it. Again, part of our analysis, we came up with that 450 gigabyte per pair information, and we built a formula that will allow us to figure out, based on the estimated amount of data, how many resources do we need to spin up to accomplish recovery time objectives. At that point, I will hand this back to Jonathan for discussion of the remainder of the results.
Awesome, thank you, Aaron. So let's talk about the outcome of the project. So we're proud to say that based upon our initial estimates, we were able to save over 82% in terms of storage. Our budget came in 90% under what we initially thought it would. This is mostly due to the built-in functionality of Cribl and being able to really get a high and good compression rate on that data, along with our work with AWS and doing the AWS tiered storage, where we're able to move the data into cheaper storage over time as the data begins to age. And of course, time. All of you managers out there and all of you engineers out there know that these things have to be done on a timeline. So I'm proud to say that with the support of the Cribl team and my genius Aaron here, we were able to get this figured out and done 3 weeks ahead of schedule, which made everybody up to the highest levels very happy with us. So this goes a little more into detail on that. So once again, we got about 83% compared to the raw data volume for our compression, based upon us using the built-in formulas that are available in Cribl. And via AWS Intelligent Tiering, we're able to automatically have the data moving between tiers such that it costs less money over time, as long as it's not accessed. Because remember, as soon as you start accessing data, for example, if you have to do replay, after the data has already been put inside of AWS S3, you oftentimes will be graduating that tier back up to a more expensive level. So you just have to be cautious with that. But of course, if you're trying to recover from ransomware, it's a part of business. I'm sure you have bigger problems than worrying about the immediate cost of that storage. And I'm sure that leadership would forgive you if you're able to get back all the data that has once been compromised. So this is a basic graph which kind of talks about or shows how much the costs were over time from month to month. Of course, as you build up, you start sending the system data, it will initially, the cost will ramp up. But once you start flowing the data off into the AWS inside of the tiered storage, the costs pretty much flatline over time. And then eventually you can anticipate what the cost will be and be able to have those ready for your budgets for the following and future years. So it's very predictable as long as your ingest rates remain relatively static over time. But of course, as they go up, the cost will go up, but because the storage is so cheap in comparison to having it actually an on-prem solution or other solutions, it makes business sense for us as well. So let's talk about the future. So one of the big things that we're working to do is to do more and more with our Cribl and with our Cribl license. So we're going to continue our efforts to make our data, as they say, quote unquote, AI ready by making sure that we have data in a ready state depending upon the end platform or the MCP or whatever it is that needs access to that data, to where we can work to have Cribl part of our solutions in the observability space, be able to help our agentic AI platforms that we're working on developing have the data that they need to make those critical decisions. And a part of that, of course, is enabling our research and development teams, which are really the branch of Leidos that does that hard work in terms of like agentic AI development, and also developing mission systems for our government customers and contracts. And we are able to feed them live data oftentimes using our Cribl implementation so that they can understand what does real world data look like as been generated across the Leidos enterprise. Then one of my main goals, probably much to the chagrin of another vendor, which we won't speak of, is to drive down the cost of how much our license is over on the Splunk side, basically. Because with this solution, we're able to then make better choices in terms of what we actually send to Splunk versus what we just store inside of S3 for like the need of meeting a compliance objective. And of course, with Cribl Replay, we can call back any event in case someone needs to see it. So we have basically a well thought out solution that enables us to make better decisions in terms of what data we actually have to hit that Splunk license moving forward. And then our future goal, is to just basically do that and make sure that we have the right data hitting there. And if we don't need to actually send it to Splunk, instead of just having it be replayed there, we can also do things like aggregation, sampling, and other reduction functions to make sure that our costs can be as controlled as possible in the future. And the final thing that we're working on is a native search interface to be able to query the data directly in S3 if need be, which of course would be one of the best options for us. But we're also considering things like Cribl Search, which also has that capability, but that's still kind of a work in progress. So that's what we're planning on doing in the future. All right, and I'm not sure if we can take questions now if we have time, or might need to take them in the hallway.
Yeah, I think we can take them if you guys are comfortable. We have a few minutes if anybody wants to. Right here.
Yeah, good afternoon. On that last slide, on the very last point that you had made as far as that native search interface, is that going to be for a targeted set of end users, like maybe security only or fraud departments, or is it going to be for open to everyone?
It really all depends upon how we're able to, of course, maintain our controls about like role-based access, because that would be the biggest thing. If I can make it available to everyone in the organization, 100% I'd do that. But it depends upon how we're interfacing with that data, what kind of controls we can put around it, whether or not we can provide broad level access or need to constrain it more.
And then a secondary question to that, nothing's for free. So with that role-based access, would you also probably implement a chargeback to access that data, instead of it all coming out of your budget for people to search against that data?
So based on I know it varies from organization to organization, but based on how our organization is set up, we provide it as a service, better empower the business. So we don't have active chargeback models where we're doing it in that form. But I'm sure that you could, in the case that you needed to, a model could very well be created in order to meet that need. Us ourselves, we don't have that current constraint, so that's not a need at the time for us right now. Yeah, so I think he has a question over here, and then the gentleman in the red shirt over there has one as well.
So related to the compression that you have by sending things up to S3, is the compression ratio that you're achieving based solely on the fact that you're using that data only for catastrophic events?
No, that is actually the default compression that we are getting just moving this data through Cribl and into S3. That is their standard compression for the JSON and the way they handle the tarring of the files.
So is that the expected compression you would get if you were to use search in front of that, Cribl search in front of that?
I'm sorry, say that again?
So if you're going to go ahead and implement that last bullet using Cribl search, you would expect that kind of compression up there as well? Or does it have to be uncompressed for search to use it? And you probably don't know the answer to that.
I don't know the answer to that. I believe you would probably have to uncompress that data in order to be able to search it, but I'm not 100% sure of that.
Yes, a quick question. So you mentioned that you stood up a Splunk search heads and indexers in AWS. They pulled data directly from S3. Is there any charge for that? Do you guys get charged for that at all? Because it's a region or inter-area?
So based upon where those things are set, we don't, they'd be in the same account, and like the example we had for our recovery environment. So as they're in the same account, to my understanding, there's no charge outside of the compute charge to move that data back and forth from S3. You get the charges once I believe you start moving data from S3 back to like an on-premise location or somewhere else where there is like a charge for exfilling and sending the data outside of the network. But the cost we had, the major costs, of course, are the compute workloads that are required in order to actually house those larger indexers and search heads for that environment. That would be honestly temporary until you could find out what happened and recover and restore things back to normal. But yes, taking the data outside of that AWS account in that environment, there would be a charge in terms of the movement of the data back into another system that's outside of there. Welcome.
So I have two questions. And first of all, I'm curious, why did you pick CloudFormation over Terraform in your environment and for this infrastructure? And the second question is, you said you used AWS API keys in retrieval of S3 logs and connecting AWS. Why didn't you use IAM roles instead of why did you pick using API keys over IAM roles in your infrastructure?
So I can answer the first question at least. The first answer to that one is that we had expertise on staff with CloudFormation templates, and that's what we had available to us at the time, being a little bit over a year ago now that we first went down this route. So because we had the expertise and they already had similar environments set up for a service that we provide to the organization for kind of pre-hosted cloud solutions, we just kind of modified those templates to meet the needs of this new solution. We do have expertise now with Terraform. I know that, to my understanding, that is kind of a cloud agnostic solution. So in the future, if we had to do this in Azure or GCP, we might then be able to use Terraform. But that was just, we were all built in AWS, so it worked for us in that way that time. In terms of the other question, I'm not sure, Aaron, will you happen to have the answer?
That was regarding the AWS authentication method?
Yes, API keys. You said use API keys for authentication, AWS. I know you have big and critical data. Why didn't you pick IAM roles for your EC2 instances that you are using for?
There is actually a combination of both in use there. The IAM roles are defined inside our template. And we have specific ones that prevent that data access from anything except the account that we've set up for it. But the AWS keys grant that specific access to that bucket in addition to those roles. To be quite honest with you, I am not super familiar with AWS. I don't know why I was told that was the best way to do it, but our team that handles that told me that's how they wanted it done. If there are additional questions, we will have to take those in the hall. We are holding up some other people here. I appreciate everybody's time today. Thank you.
Thanks, everybody. Thank you. Thank you both for presenting.